Well, here was our 2-3, and here goes our lesson on 2-4. We are drawing tree diagrams and probability models. Here's a nice little GIF of some fall colors. Hopefully you're getting out at some point, maybe this weekend or maybe Monday or Tuesday, looking at the nice trees and thinking about the probability problems. All right, a couple things here. Few things. How do we build and properly notate, means to write a tree diagram? How do we calculate probabilities using that same tree diagram? And again, is the tree diagram correct or not, right? How do we know? How do we verify? And finally, being able to build a model by using a tree diagram. And that's just basically laying out all our work when we're done. All right. Tree diagrams. Let me illustrate using this particular tree here that's been sketched out so lovely. We start a tree diagram at the leaf. Remember, those were the things that we counted back in chapter 1. Now what we're going to do is we're going to start with that leaf and we're going to follow our path back to the trunk, and every portion of the tree is going to of the branch will represent another probability. And those probabilities are going to be multiplied together. So to find any individual probability, so the probability of that leaf there, I have to multiply all those different probabilities along the branch back to the trunk. So let's write that up. To calculate, multiply each branch going back down the tree. Finally, to verify that you've done a proper probability, take each of these leaves, yes, that you've ended up at, which is each representing a probability, add all these different leaves up, and you should get the magic 100%, aka 1. All right? So let's look at a little sample one here. This you've seen before. It's like a little coin toss. Here's our first coin being tossed. Here's the second coin being tossed. And again, we have two pairs because it could fall heads or tails, or it could fall heads or tails, right? Either way. And then our third coin being tossed. All right, so let's look at this with a tree diagram. Each branch represents a probability. In this case, the probability is 1/2, regardless of the way that we go. So we're going to mark each branch with a 1/2. And then we're going to pick one, and I picked it by marking it with purple, a particular leaf, a particular outcome, and we're going to calculate its probability. Now, not every tree diagram will have equal probabilities on each one, but in this one, because it's a coin toss, it is. So let's first of all look at what was this particular outcome that I circled in purple. I ended with a tree, a tails. Before that I had a tails, and before that I had a heads. So that this outcome is heads, tails, tails. And to get the probability of this one, what we would do is take each of those numbers. So let's write this as probability of HTT is going to be 1/2. Yeah, I'm going to take this 1/2, and then I back down the branch. I grab that half, and then I back down again and grab that. So I've got 3 1/2s, and I need to multiply them all together. So my probability of HTT is 1/8. And in fact, each of these probabilities, because let's just randomly grab another one. Yeah, let's grab this one down here. So notice again we have a probability of TTH. And again, notice if we look at the branches going back down, we get like another 3 halves. So we're going to get another 1/8. And that's good to know because we have 8 leaves, so we have 8 outcomes for this particular problem, and if we add up 1/8 8 times, why that's like taking 1/8 times 8, which is 1, which is the 100%. All right? On this next problem, we won't have equal probabilities going each way. So that's going to like change it up a little bit. All right, restaurant. You have 2 delicious breakfast platters offered. One features pancakes as a special. The other one features just eggs. Yeah, and beverages that go with that are milk, juice, are milk or juice. No coffee, oddly enough. Okay. Now, we know that 30% of customers choose the pancake platter, while 70% choose the egg platter. And 40% of customers choose the milk, while 60% of customers choose the juice. I clearly would not be attending this particular joint restaurant. So we have 30-70, 30 choose the pancake, love the pancakes, and notice that accounts for 100, those two, and then 40 and 60 for the beverages, 40 milk, 60 juice, and I agree with the juice people there. All right, so let's go ahead and make ourselves a little tree. Notice our first one we're going to choose here is eggs and pancakes. So notice we have 70% here, 30% for the pancakes. Right? Once you choose the eggs, now you have to choose milk or juice. Again, 40% of the people choose milk, 60% of the choose juice. And likewise, we come down to look at the milk, and same thing, with the pancakes. We have 40% milk, 60% juice. So now let's look at each of these leaves. This first one up here would be the probability of choosing eggs and milk. Let's put a comma between them. And the way we do that is we multiply each of these probabilities, 0.7 times 0.8, 0.4. Hopefully you can do that mentally, because 7 times 4 is 28. We move the decimal spot 2 places. Yeah? Sure enough, 28%. What is the probability now of choosing eggs, right, and juice? Why, we take the 70% and the 60% and multiply those. And that gives us 0.42. Double checking, yes. And then pancakes and milk. Seems a little too sweet for me. 0.3 times 0.4. So that's 12%. And then the probability of pancakes and juice is 0.3 times 0.6. 0.18. All right? Now we want to verify, did we do this right? Well, we could add 28% plus 42%. That's 70%. 12% and 18%, that is 30%. And sure enough, 30%, 70% give me 100%. So I know that I have done it. I've done the tree right? I haven't left anything out. Now, just to summarize, right? Looking at each one, what is the probability? Here's my model now, of eggs and milk, 28%. Eggs and juice, 42%. Pancakes and milk, 12. Pancakes and juice, 18. Now this is important to know because as you have a restaurant, you have to order the product ahead of time. And if you know your eggs and juice are the most popular, then that's what you need to have in advance and be prepared to deliver. And then again, you can offer price points and specials with that, knowing that people want that particular one more than others. All right, very important analysis that goes on there as you market items. All right, lastly, we're going to look at a baseball game between two teams, Diamonds and Dusters. And they're doing a little playoff, a best of 3, which means the first one to win 2 games wins the series. We know that from past experience, the Diamonds win 60% of the time. Dusters only win 40% of the time. All right, so we're going to come in here and build ourselves a scenario. Diamonds, Dusters. So 40% for Dusters, 60% of the time for Diamonds. So the first game, right? There it is. Somebody wins. Okay? Let's follow the Diamond path. Diamonds win the first game. They have another match, right? Again, that match, the Diamonds have a 60% chance of winning. So Diamonds won the first match. They won the second match. 0.6 times 6 is 0.36. So we can stop there because the Diamonds have won the tournament, right? They've won 2 in a row, swept the series, and that's going to happen 36% of the time. Now, let's look at, well, what is the probability of, let's say, the Dusters winning the second game? Now it's even up. Now we have to play one more game. So the Diamonds and the Dusters will play again. And again, it's 60-40 split again. So this time, I would need to take 0.6 times 0.4 times 0.6. Yeah? And if I multiply those 3 numbers together, I get 0.144. So that gives us about a 14% chance. And this would be in a best of 3. The Diamonds have won 2. Right? All right. The next probability is the probability of the Dusters coming from behind, winning the last 2 games. Right? So now we have 60, 40, and 40%. And multiplying those out, we get a probability of 0.96 or 9.6% chance of the Dusters coming from behind. And again, we can come down here and look at, similarly for the Dusters, what would happen if they were to sweep the series, right? They win the first one 40%, win the second one 40%. So together, it's 16%. And likewise, the Diamonds, like coming from behind, winning the second, winning the third match, that would be 14% of the time. And then we would have the Diamonds winning, and then the Dusters winning the third and final, taking the series, and that would happen 0.96% of the time. So if we add up Diamonds win, Diamonds win, Diamonds win, right? Those 3, we get 6.648 here. And that tells us that the Diamonds have a probability of winning the series 65% of the time. And the Dusters will win it 35% of the time. All right, and so there we go. We can show it separately as the Diamonds winning in 2, or the Diamonds winning in 3, the Dusters winning in 2, or the Dusters winning in 3. All right. Well, I'm going to pause there. This next one here is kind of interesting because it gets into a card game, and it's looking at getting a red card and a face card in either order. I'm not going to go through it, extends it here. I don't think you need to know this. Good luck on doing your worksheet. You're not doing problems from the set here in the book. There's an attached worksheet, and do those. Good luck, and we'll see you on Monday, and hopefully they go well.